If you scaled an ant up to the size of a dog, it would suffocate and shatter under its own weight before it took a single step. The same unbreakable law of physics is the reason the largest creature that has ever lived can only survive by never leaving the water. Every animal on Earth is trapped inside a set of invisible walls that decide exactly how big it is allowed to get. And once you can see where those walls come from, you can see the hard ceiling that nothing alive has ever managed to break. To find that ceiling, picture lining up every animal on a single ruler, from an ant a few millimeters long to a blue whale the length of 3 school buses. As you climb that ruler, you don't run into one limit. You run into 4, one after another: structure, oxygen, gravity, and energy. Each one stops a different kind of animal from ever getting any bigger, and each one is about to reveal something strange about the shape of life itself. The first wall is pure geometry, and it's the reason our ant could never be scaled up. When you double the length of any animal, its weight does not simply double. Volume grows with the cube of length, so the body becomes 8 times heavier. But the strength of its bones and muscles depends on their cross-section, which only grows with the square, so it becomes just 4 times stronger. Weight races ahead of strength every single time you scale up. Make an animal big enough and its own skeleton can no longer hold it. The bone reaches the point where it snaps under the body it is carrying. Scientists call this the square-cube law, and nothing in biology escapes it. That law reaches some animals far sooner than others, and insects hit it almost immediately. An insect has no lungs. It does not actively breathe the way you do. Instead, oxygen seeps into its body through a network of tiny tubes, drifting inward on its own until it reaches each cell. That passive trickle works beautifully when you are small, but the bigger the insect, the further the oxygen has to travel, until the very center of the body can no longer get enough to survive. That is the second wall, and it is why, no matter where you look today, you will never find a beetle the size of a cat. But that wall can move, because if the problem is how much oxygen is in the air, then change the air, and you change the limit. Around 300 million years ago, in the Carboniferous period, Earth's atmosphere is thought to have held far more oxygen than it does now, somewhere around 30 to 35%, compared with 21% today. And in that oxygen-rich world, insects did something they simply cannot anymore. Dragonflies grew into giants with wingspans reaching 60 to 70 centimeters wider than a hawk. When the oxygen faded, so did they. High oxygen is still the leading explanation rather than settled fact. But it is a stunning hint that these walls are not fixed. They move with the planet. On land, the third wall is gravity itself, pressing every heavy body straight down into its legs. The largest living land animal, the African elephant, tops out at around 6 tons, and even that demands legs like pillars planted directly beneath it. Push further back into history and you find the largest land mammal that ever walked, Paracaritherium, a hornless relative of the rhino that may have reached 15 to 20 tons. But notice what is missing. Nothing on land has ever come close to the giants of the ocean. On land, gravity always wins first. And yet the dinosaurs seem to break that rule. The largest sauropods, long-necked titans like Argentinosaurus, may have reached 50 to 70 tons, far heavier than any elephant. So how did they carry themselves? They cheated. Their bones were not solid. They were riddled with hollow chambers and air sacs, a lattice that stayed strong while shedding an enormous amount of weight. It is the exact same trick used by the animals flying over your head right now. Birds, a giant that lightens its own skeleton, can push against gravity a little longer, but only a little. Even the sauropods eventually ran into a ceiling. So if gravity is the wall, there is really only one way to get around it. Stop fighting it. Take that same impossible body and lower it into the sea. In water, buoyancy pushes upward on every part of the animal, cancelling out the pull of gravity almost entirely. Suddenly, the skeleton no longer has to hold the body up at all. The water holds it. An animal that would collapse instantly on land can float, weightless and enormous, supported everywhere at once. The ocean does not just allow giants, it is the only place they can exist. Which brings us at last to the animal waiting at the very top of the ruler. The blue whale reaches up to 150 tons and 30 meters long, heavier than any dinosaur ever found, the largest animal known to have existed anywhere in the history of life. Its heart alone can weigh around 180 kilograms, and every gram of that body is only possible because it never has to stand up. Lift a blue whale out of the water, and its own organs would begin to crush it from the inside. It is a giant, built entirely by the sea, but even the ocean has a final wall, and it is not strength, it is food. A body that big is a furnace that never stops burning. A foraging blue whale can eat somewhere between 10 and 16 tons of krill in a single day, far more than older estimates ever suggested. And here is the trap. The bigger an animal gets, the steeper that food demand climbs, rising faster than any body could realistically feed itself. Push far enough, and an animal would need more food than it could ever catch just to stay alive. That is the fourth and final wall, energy, and the blue whale is sitting right up against it. Think about what that really means. The blue whale is not just big. It appears to be almost exactly as big as the laws of physics on this planet will ever allow. The biologists who model these limits keep landing on the same uncomfortable conclusion. A giant filter feeder in the open ocean is brushing right up against the theoretical maximum size for any animal on Earth. We did not simply find the biggest animal alive. We may have found something very close to the biggest animal that can ever be. Put them all on one line and the scale becomes almost impossible to hold in your head. The ant, a few milligrams. The elephant, 6 tons. Argentinosaurus up to 70. And the blue whale, 150, outweighing the greatest land animals that ever lived, stacked one on top of another. A single blue whale weighs about as much as 25 elephants. Its heart is the size of a grown person, and all of it obeys the very same law we started with, the one that crushed a scaled-up ant in the opening seconds. So here is the final thought. These 4 walls are not laws of the universe. They are laws of this planet. Turn down Earth's gravity, or turn up its oxygen, and every ceiling we have talked about would rise. On a different world, you could in principle build something larger than a blue whale, but here, with this gravity and this air, the ceiling sits exactly where the blue whale floats. The same physics that sets the maximum size of life is the physics that shattered a dog-sized ant before it could take one step. From the smallest body to the largest, one law holds both ends of life in place. The blue whale is not big by accident, it is big right up to the edge of what is possible, and not 1 gram more. If the invisible rules hiding behind the natural world are your kind of thing, subscribe and stick around, because there is a whole planet of them still left to uncover.